In problem number 10, a bakery is making a whole wheat bread and apple bran muffins. For each batch of bread, they make $35 profit. For each batch of muffins, they make $10 profit. The bread takes 4 hours to prepare and 1 hour to bake. The muffins take 0.5 hours to prepare and 0.5 hours to bake. The maximum preparation time available is 16 hours. The maximum baking time available is 10 hours. How many batches of bread and muffins should be made to maximize profits? When they ask me in this problem to maximize profits, this means that my objective function needs to be about maximizing profits. So my objective function is going to have this variable P, which stands for profits, and I need to look in the problem and see how I make money. I make money in this problem with bread and with muffins. So I make $35 for each batch of bread that I make, 35B, and I make $10 profit for each batch of muffins that I make, so that's 10N. So this objective function is what I'm trying to maximize or minimize, and I've also just had to come up with a B variable and an M variable, and the B variable is the number of batches of bread, and the M variable is the number of batches of muffins. In the problem, they give me constraints. Now, two constraints are not listed and are never listed, but you just need to know these two constraints because this word problem is about the number of batches of bread and the number of batches of muffins, and you can't have negative batches of bread or muffins. So two constraints that are not listed are the fact that B is greater than or equal to 0, and M is also greater than or equal to 0. Now, up in the paragraph, there's more constraints, and some of these other constraints are that there's prep time. So the bread takes 4 hours to prepare, and the muffins take a half an hour to prepare, and the maximum prep time that I have available is 16 hours. So that means that all the time that I use to make my batches of bread and muffins has to be less than or equal to 16. So I have 4 hours for each batch of bread, and then I add that to half an hour for each batch of muffins, and that must be less than or equal to 16. And this equation is about the restrictions or the constraints on my prep time. The second constraint that's listed in the problem is my bake time, because I only have probably one oven, and I have limited space for baking. So the maximum amount of time that I have to bake in the problem is 10 hours. And for baking the bread, it takes 1 hour. So it's 1B. So every time I want to bake a batch of bread, it takes 1 hour. And the muffins only take half an hour. So that is 0.5 times for each batch of muffins, excuse me. So if you take note, here are my 4 constraints in this problem, and those are the constraints that I have to graph on a graph and find the vertices. And once I find the vertices, I need to plug them in to my objective function. So this is the setup for problem number 10. In problem number 11, it's about a phone bill. On a typical long-distance call, you talk for 30 minutes. On a typical local call, you talk for 10 minutes. Your phone company offers a special low rate of 0.8 cents per minute for long-distance calls and 3 cents a minute for local calls for customers who spend less than 240 minutes on the phone per month. Your parents have set a limit of no more than 15 long distance calls per month and 10 local calls per month. How many minutes of long distance and local calls should you make to qualify for the special rate plan and minimize your phone bill? So, because you want to minimize your phone bill, your objective function should be about your phone bill. So, the cost of your phone each month is equal to 0.08 cents for each minute of long distance phone calls, so there's my L variable, plus 3 cents a minute for local. So for local, I'm going to use X. And I'm going to declare my variables, L and X. So what are my constraints? Well, the two that are never written but are supposed to be understood are the fact that the number of minutes on a long distance phone call has to be greater than or equal to 0, and the number of minutes on a local phone call has to be greater than or equal to 0. Again, those two basic constraints are not listed, but I just have to know and understand that my number of minutes of local and long distance phone calls can't be negative. It has to be greater than or equal to 0. So what are the other constraints in the problem? There are some more constraints in the problem. The first one deals with that I need to spend at least 240 minutes on the phone per month. So this constraint means that my number of long distance minutes plus the number of local minutes must be at least 240. So that is greater than or equal to 240. Now there's two more constraints, excuse me. My parents tell me that I can only make 15 long distance phone calls per month. But up here in the problem, it says that every time I make a long distance phone call, I'm on there for 30 minutes. So that means my number of long distance minutes is going to be less than or equal to I make 15 calls, and each of those 15 calls are typically 30 minutes. So this is L is less than or equal to 15 times 30, and 15 times 30 is 450. So this is L is less than or equal to 450. Now I need to do the same process with local minutes, because my parents come along and also said that I can make only 30 local calls per month, and typically I'm on the phone for 10 minutes each time I make a local call. So that means that X has to be less than or equal to 10 times 30, and that's an easy math problem you can do in your head. 10 times 30 is 300. So my 5 constraints I'm labeling right now. 1, 2, 3, L is less than or equal to 450, and X is less than or equal to 300. Those are the 5 constraints that I need to graph in this linear programming problem.